So we're going to take a look at something called molar mass and molar volume now. You may have wondered during the last video when we saw a little flask full of a mole of water or a mole of iron, how do I know there's a mole in there? Clearly I'm not counting atoms. I can't see atoms or molecules or formula units, and there's a ton of them in a mole. We already talked about how fast a processor would have to be to even count to that in 300 and some odd thousand years. So how did I know there was a mole of iron or a mole of sodium chloride or a mole of water in those flasks? Well, the key really is this idea of molar mass and molar volume. Now, you're going to want your periodic table out with you so that you can follow along when we're talking about molar masses. So stop the video and grab that if you don't have it. All right, let's take a look, for example, at molar mass. Now, the definition of molar mass is it's the mass in grams of 1 mole of a substance. So if there's a way for me to figure out how much 1 mole of a substance weighs, then it's easy for me to measure out a mole of iron or a mole of water, for example, or a mole of sodium chloride. All I have to do is know how much does 1 mole of those substances weigh. What's the mass of 1 mole of those substances? And then it's easy. I just go to a balance and measure that out. It's a really easy way of measuring out moles. We don't have a molarometer. We don't have an instrument that's designed to measure moles, so we have to do it this way. Okay? To find the molar mass of an element, it's really easy. Just grab your periodic table, and it's the same as the average atomic mass. That's the number in red underneath usually, only in grams instead of AMU. So it's really easy. So if you wanted to find the mass of a mole of neon, for example, it'd be 20.179 grams. Okay, the mass of a mole of bromine, just the bromine atoms, is 79.904 grams. Okay, now to make things even easier, we always round to 1 decimal place. So neon would be 20.2 grams per mole. Bromine would be 79.9 grams per mole. If you went to zinc, would be 65.4 grams per mole. Okay. Now, if it's a compound, you're going to calculate the molar mass simply by adding up the masses of all of the elements in that compound. So you'll need a formula to start with. Let's take a look at a couple of examples so that we can see that. So let's say that we want to find the mass of a mole of CH4, methane. Okay? Well, what's in CH4? Well, there's 1 carbon and there's 4 hydrogens. Okay? So now I'm going to go to the periodic table and I'm going to find out that the mass of carbon is 12.0 grams. So 1 times 12.0 grams is 12.0 grams. Easy enough, right? And I look at the periodic table for hydrogen and it's 1.0 grams, but there's 4 of them, so 4 times 1.0 grams is 4.0 grams. Now I simply add them together and I get 16.0 grams per mole. Okay, that's how you find the molar mass of a compound. Now be careful. If, for example, you have a compound like lead 2 nitrate, PbNO3 2. When you're figuring out what's in there, well, I've got 1 lead, so 1 times the molar mass of lead. Go to the periodic table, find lead, 207.2 grams. Now this 2, though, this 2 under here, it actually distributes over both of these. So I have 2 nitrogens, 2 times the N inside. Okay, so that's 2 times 14.0. And that's 28.0 grams. I'll just add this on top here just so that we can add in a vertical column. And then I have 2 times 3 is 6 oxygens. So that's 6 multiplied by oxygen's molar mass, which is 16.0. 15.9994 becomes 16.0 when I round to 1 decimal place. Okay? So that's 96.0 grams. So now I add all these up. I can pop out a calculator here. Let's do 207.2 plus 28.0 plus 96 is equal to 331.2 grams per mole. Okay? So that's all there is to do to finding molar mass. If it's a compound, you're just going to have to add up all of the molar masses for all of the elements in the compound. And if it's an element, you just look it up. So we can use this now as a conversion to figure out, well, what if we don't have exactly 1 mole? What if we have a fraction of a mole, or if we have, more than a mole, and we wanted to measure out its mass? What would we do? So, for example, let's say we need 2.50 moles of sodium chloride for a particular experiment. What mass of sodium chloride should we go and weigh out? Okay. The first thing I need to answer this question, because I see that I'm talking about mass, is molar mass. So I need the molar mass of NaCl. That's 1 sodium, which is 23.0, and 1 chlorine, which is 34.5. Add those together, you get 58.5 grams per mole. And that's my molar mass. That's what I'm going to use in the problem. Okay. So again, draw your little cross, take the number that are given in the problem, in this case 2.50 moles, and put that in the upper left. Now moles is the unit up there, so I want moles in the denominator of the next fraction. All right, well, it's 1 mole is equal to, for sodium chloride, 58.5 grams. I put the grams on the top because that's going to allow me to cancel out moles and leave myself with grams, which is what the problem's asking me about. The problem is asking me how many grams, what mass. So once we've canceled out moles, we're left with grams in the numerator. We're just going to multiply 2.50 times 58.5. We get 146.25 grams of sodium chloride. Again, try to keep the number to a reasonable number of digits, right? You don't want to have 18 decimal places in your answer. Round it to 1 or 2, depending on your how you feel you need to express the number. We can do this the other way too. Let's say that we want to know, we have a mass, we know we're working with 35 grams of water, and we want to know how many moles that would be. Okay, so again, we need the molar mass. Whenever you see a problem that's asking you about mass of a substance, you need the molar mass. Now, the molar mass of water is 18 grams per mole. I will let you figure that out on your own. Go and maybe stop the video here and figure out the molar mass of water just to make sure you understand why it's 18. Okay, again, set up your little cross. Take the number that's in the problem, 35 grams, put it there. Now we have grams in the numerator of this fraction. We want grams in the denominator of the next fraction. And if you look just above here, molar mass of water is 18 grams per 1 mole. So I'm going to put 18 grams on the bottom and 1 mole on top. And that way I'll be allowed to cancel out grams, leaving me with moles. Now this is a division, 35 divided by 18. Okay, so it's 1.94 moles of H2O. Now, the other thing that we want to understand about moles is something called molar volume. Right? The definition of molar volume: 1 mole of any gas at standard temperature and pressure occupies a volume of 22.4 liters. Okay, 1 mole of any gas. Doesn't matter what the gas is. If you have 1 mole, if you have 6.02 times 10 to the 23rd particles of that gas at a particular temperature and pressure, if you think about it, gases are affected by temperature and pressure. You know what happens perhaps to a balloon if you put it in the freezer. It shrinks, right? Because you lower the temperature and it changes the volume of the gas inside the balloon. If you throw an aerosol can on a fire, it'll explode. Why? Because the pressure increases if you increase the temperature. So in order for this relationship, 1 mole having a volume of 22.4 liters to be true, we have to be at a specific temperature and pressure, and that's standard temperature, which is 273 kelvins or 0 degrees Celsius, and standard pressure, which is 101.3 kilopascals. kPa is kilopascals. It's the SI standard unit of pressure, which is equal to 1 atmosphere. If those are the cases, I can write this relationship. 1 mole is to 22.4 liters, or 22.4 liters over 1 mole, depending on what kind of problem I'm doing. So here's an example. What's the volume of 4.75 moles of hydrogen gas at STP? I'm talking about volume, so I know I'm going to be using one of those 2 conversion factors that I just showed you. Set up your cross, put the number that's in the problem in the first position, 4.75 moles. Moles is on the top, so I want moles on the bottom of my next fraction, so it'll cancel. And 1 mole is equal to 22.4 liters, provided I'm at STP, which according to the problem I am. I can cancel moles out. Now I multiply 4.75 times 22.4, and I get 106.4 liters of H2. I can do it the other way. How many moles of NH3 at STP would have a volume of 55.0 liters? Stop the video and try this one on your own. All set? Let's see if you did it the way I did it. There's my cross. The number given is 55.0 liters, so that goes in the upper left. Liters is in that unit, so I want liters in the bottom, which means I put 22.4 liters down below and 1 mole on the top. And that allows me to cancel liters. Now it's 55.0 divided by 22.4, 2.46 moles of NH3. Is that what you got? If so, you're on the right track. We've got 3 different kinds of calculations now involving the mole: particles, mass, and volume. Now we get to start putting them together in problems to make for more powerful calculations. But get a handle on those 3 first.